Okay, are
And let's
you
see
in? I don't
what's
see
going.
you in yet. Oh, I see you.
Yeah,
Okay, do you go by Min?
yeah, I do go by Min.
All right, awesome. Okay, anything you want to say about yourself? A quick introduction at all?
Sure. Hi guys. I've been a long time lurker of the TCN Discord channel, and happy to be the first time here.
Have you watched any previous streams at all? Or is this your first
Yeah,
time?
I've watched a few.
Okay,
I've
great.
watched a few. I try to watch as much as I could,
Yeah, yeah,
but
for sure. No,
I
I'm
have
just
some
I'm just
commitments
curious. I'm just
anyway.
curious. Yeah, it's
Mm,
no big deal at
yeah,
all.
yeah.
Okay, so let's get started. So how this work is Python your preferred language? By the way, we can switch it to your preferred language.
Yes. I'm just gonna switch to C++. plus
Okay,
plus.
yeah, that's cool. That's totally chill. Great.
Yep.
Okay. Do you prefer a heap question or a string question today? Today I'll give you the choice
Ooh.
because I didn't prepare very well for this one because I switched it
Mm.
up. But do you have a
No worries.
preference?
Heap question or string question? Let's
Yeah,
do string.
string. Okay,
Let's do
great.
string. Yeah.
Okay, so the question today will be given is, um, I'll be dictating this. I'll be saying it. You're free to take notes and ask clarification
Mm.
questions after as well. Okay, so
Okay.
in this question, I'll be giving you a list of strings
Mm-hmm.
and to the input of this function, and I want you to return me a list of group of strings where each
Mm-hmm.
group of strings are all anagrams of each other.
Oh, I see. I see. Return group of strings that are anagram.
A list
Okay, I
of
see, I
group of
see.
strings.
Oh, listen.
They may be more than one group of strings. There may
I
be,
see.
not necessarily.
I see, I see.
Hmm.
Mm-hmm. And is that all?
Yeah, that's all.
Sounds good. Let's see.
I think you're too used to
So
the
it's,
OOD questions where the description's about 10 minutes. This is just a
oh,
Leetcode one,
yeah.
so it's just very quick.
uh,
Hmm.
Oh, yeah, yeah. Um, yeah. Let's get started then. So I guess one of my first question is like, with just the problem statement, I'm not really clear what the input is gonna be.
Okay.
So is there any constraint on the list of strings? Like, is it only lowercase English character? Are there any character signs? So I just want to clarify that.
We can assume it's just lowercase English for now.
Lowercase English.
Yep.
Okay, sounds good. Okay, English as input only. Okay, sounds good. So lowercase English list of string and a list of groups of strings. And I I guess the returning the output would be a 2D arrays, right? And each array would be different groups. Is that correct?
Yeah, that's fine.
Okay, sounds good. And okay, sounds good. And this might be a stupid question, but also like the group of string that I return, like can it be modified or is it the original string when I return it?
Oh, that's interesting. Can you clarify what modifying means in this context?
Yeah, yeah, for sure. Say for example, I sort the string and I don't bother I don't bother mapping the
Oh
current
no, it has to
like
be
the
it has to be
sorted
the
string.
original string.
I see, I see, I
Yeah.
see. Okay, sounds good. Um, okay, so returning original. Okay, that looks good. Okay, okay. Um, so yeah, so for questions like these, when there are anagrams, I would just try to um um redefine, well, not redefine, like um clarify what anagram is so that we don't have any misunderstanding. So I guess an anagram in this case would be that the string, if string A and string B are anagrams of each other, that means that A and B use the same set of characters with the same frequency. That sounds about correct,
Yeah, that sounds
right?
right. Yeah, that sounds right to me.
Okay, sounds good. So let's see. I'm just gonna write out a few outputs and I mean a few examples so that I could get a clearer picture of it.
Okay.
So say for example, I have an array of this is hard. Uh, let's go with really simple A and B. This would definitely return there's no anagrams in this. And if I say, let's say if I have two groups of anagrams, so let's say we have AB and then BA and then C, for example. So I guess the output would be AB, BA, and then D would be the output. That seems about correct.
I want to clarify this case here. Is this like this
Hmm.
the output is
Oh,
empty?
oh no, sorry, I forgot to write that in. Yeah, this should be like this actually. Uh,
Yeah,
how about that?
that looks good to me. Yeah, yeah.
Okay, sounds good. Sounds good. Okay. Now that I have a good mental picture of what it is, um, at first I think I'm just gonna write out um the function signature and the input of it. So we know that it would return. Ooh, oh my. So include. Do we have vector in here? We do have vector. Okay. Let's say vector. ah, It should be correct. Anyway, so right. I'm not too used to this yet.
That's all right.
Let's say so that would be string. Yeah. And then let's call it group anagrams, for example. Okay, and like we mentioned, this include string. There you go.
I think you have an extra closing brace.
Thank you. Okay, okay, that was awkward. Let's try to get this through. So I guess the first, oh yeah, I guess there would be only one input. That would be a list of string, right? And just call it array, for example. Um, okay. So for questions that involve anagram, um, so anagram are just since it's the same set of characters and the frequency doesn't matter, that means that the order at which I use the characters don't really matter between two string, for example. So say for example, if I have a like app here, like BA here, like I could they are essentially like we don't really care about the order at which the character appear in. It's mostly just the frequency.
Mm-hmm.
So that means so that means that two so to provide like a more simplified definition of anagrams, that would just be like two strings or anagrams of each other if they have the same frequency of characters. And does that make sense if with like the definition?
Yeah, I think that does. Yeah.
Yeah, okay. Sounds good. And at the top of my head, I'm thinking of using a hash map to count how many for each string, I would count how many characters, well, how many, well, for each string, I would count the frequency of each distinct character in it. But the main problem that I see with that approach is that I still need to be able to have distinguish a hash map um, of the distinct, like a hash map of like five A's and two B's are different from a hash map of three A's and uh, two C, for example. And that would be pretty difficult um, without having to brute force through like all the entries or create some kind of like a hashing functions to make sure that two two hash maps are the same. And that would also and that would also like create extra space as well. So I don't really like that approach. But another approach that
So
we
just
could
to
also
hold on,
do
just to
here.
be clear here. So the reason you don't like the approach of using two hash maps that map
Yeah.
character to character count is because it's not easy to compare if two hash maps are the same. Was that correct? Was that correct? Okay.
Yes. Well, yes. Yes.
Okay.
Because I'm not sure like I'm not sure if in in C++, does it compare like each entry to the comparable entry? I'm not too sure how it does it, but I'm pretty sure it still go through the entire hash map to check if like go through like all the entries in hash map, and that would take a longer time. Uh, yeah.
I'm trying to
So
see. The average case is linear in size. So yes, it
yeah,
goes through.
yeah, yeah. So there's another trick that I really like to use with anagrams. That would be to sort the strings. So say for example, I have um, A, B, C, A, D, E, for example. I would sort it to a A, B, C, D, E if I know the alphabet.
Okay.
Um, yep, and let's say another string, which is an anagram of it, say A, B, D, A, C, for example. And when I sort it, it will have the same. If I sort the character in a string, it will still return the same string. So A, B, C, D, E again. So that would mean that um, so any two string that are anagrams of each other, the sorted version of it will be the same. Does that make sense? Like, uh,
Yeah, I understand.
yeah. Okay, sounds good. And we could use like the built-in library to sort the strings, but it usually take n log n. But since we have a fixed size of characters, only 26 lowercase English characters, we could use bucket sort instead, and that should be O of n. And yeah, and I'll walk you through that real quick.
Okay.
But yeah, so like the general I like approach that I'm gonna take here is that for I'm gonna loop through the the array of strings. I'm gonna loop through R, and for every string, I'm gonna sort every string, and then I guess I'm gonna store it in a hash map. Um, and that hash map will be the sorted version to the group of strings, the group of anagrams. So after I sort every string, I'm gonna insert it to the store, for example, sorted and of the current string. And finally, at the end, I would just loop through all the entries in that hash map and return. Or I would flatten the hash map into a 2D arrays instead. Does that make sense? Flatten
Yep.
hash map later. Okay, sounds
Okay.
good. Okay. So yeah, I think we could get started here. So the first thing we need to do is to iterate through uh, the array of string. I'll just say S here, for example. So what can we do? Okay, oh yeah, forgot about the hash map first. Unordered order. I cannot spell this ever map. I think I would. I think I might have to add the header file. String. Now I'll just call it results, and just gonna include an order map. Okay, that looks good. Uh-oh, that was spaghetti. Oh, I see. Yeah. Okay, so for every string, I'm gonna first sort it. So I'm gonna say sort string, for example. I'm gonna sort the string, and then what am I gonna do with the sorted string? I'm just gonna add it to the hash map. So I'm gonna do res, yeah, and push, yeah. I'm just gonna add to the group of the hash map. Yeah, that makes sense. So that's this step right here. I'm doing it right here. So for every string, I'm gonna sort it first, and then I'm gonna add it to the entry. And if the entry doesn't exist, by default, C++ should create a empty vector. So that's why I could use dot pushback here. Yeah, and now we can work on the sort string
Okay.
function. Let's see. So I want to sort a string and then return a string uh, sorted. Okay, so that would be, say, for example, I would have sort string and then string as, so I guess I would have an array of, yeah, oh yeah, I promised you that I would walk you through this, so I
That's
will
fine. You
right
can go
now. So,
fast. You just go as if it's a
okay,
regular interview.
okay,
I don't need extra babying.
okay, sounds good. Okay, okay, I'm just gonna initialize an array of 26 characters and then I'm gonna count the frequency. And let's say uh, buckets, for example, and that'd be 26 characters, and then would be 0 for every single element. Then, so for this one, we will just count the frequency of each, a plus plus. And then at the end, what I would do is that I'm gonna create, yeah, since I'm not gonna modify this, that works. I'm just gonna return a string, first initialize it as empty, and then I'm gonna go through the bucket. So what I'm gonna do is int I equals 0, buckets, just do 26 and plus plus. And now, so how do I add the character in? Yeah, I'm just gonna add this and plus I. That looks wrong. Yeah, I forgot that for the frequency of I'm gonna have to add the frequency in. So what I'm gonna do is that while while the frequency is still while the frequency is still positive, I'm gonna uh, I'm gonna I'm gonna add the character to the string, and then I'm gonna decrease the frequency. Res plus a a plus I. Yeah, that looks about right. That's frequency, and then return res. And now that should work. So what I'm going to do at the end to flatten the result is I'm going to create initialize the returning vector, the string, and then what's just call rest? Just gonna call the store. Just gonna click refactoring. And then I'm gonna call the result, and now I'm gonna iterate through the all the entries in the hash map. Forward. And now I'm just gonna care. I'm just gonna care about the groups. So which should be the second, should be the value of each entry. On that note, would there be any order for the returning results?
Can you clarify what
Or
order means in this context?
yeah, so like it could, so it could be, so the returning result, like it could be ordered by the number of strings in there, for example, like anagrams with one string go first and then two string go next and so on, or is
Oh,
it
I see.
ordered alphabetically, or yeah, is there any constraint on that, or I can return anything?
They should be ordered in where they should be ordered such that uh, the first appearance of a string in that anagram group is ordered first. So the first string that
Oh,
appears in the original vector should be in the first in its own in the return array, and then if you remove all of those anagrams out, the next string that's visible in the original array should be the second group.
oh, so like it's like a relative order, right?
Relative ordering with the tie breaking being the anagram grouping sort. Yes.
So could you repeat the last part? Like the tie breaking would be.
Yeah. So the only constraint really on the return ordering is
Mm-hmm.
that
Mm-hmm.
the first uh, the group which contains the first string in the input should be the first group in the output, and
Group
following
content
that,
first.
yeah, and then the remaining inputs will be all the strings that are not in that anagram group, and then the first of the remaining inputs should be the second group, etc. So it's ordered based on the original array.
I see. I see. Uh, so sorry, just to clarify,
Mm-hmm.
so that I could just understand this right here. So that would mean that if I have DD for here, for example, so that would mean that after the first group here, yeah, after the first group here, the next group would be DD, right?
That's right. Yep.
I see. Um, okay, that would definitely make it a little bit more challenging because the hash map store the group almost random in the random order. So how would I go about this? Hmm.
Hash maps are unordered, so you would have to track the ordering in some other method.
Yeah, I could honestly since the ordering basically depends only on the first word of the first string of the grouping. I could potentially store the first word every single time I create a new entry. Does that make sense? So say for example, I would just have a first word, for example, an array of first word.
Okay.
Does that make sense first?
I'm not sure exactly what you mean yet, but I'll see what you implement.
Okay, yeah. So let's say I have an array of first words, and then say for example, uh, so it's pretty easy to identify if we create a new entry or not.
Mm-hmm.
So say for example, if we have, let's store this thing real quick. Store sorted sorted string, and then yeah, I'm gonna sort it, and then I'm gonna check if the sorted string is already an entry. If it's already an entry, then it's not the first string.
Mm-hmm.
But if it's not an entry, then it's the first string. So I'm gonna add it to the vector of first words. And since I'm going through the list of strings in order, that would help me maintain the relative order of all the first words as well. Does that make sense
Yeah,
now?
that makes sense. Yeah.
Sounds great. So yeah, I'm just gonna quickly do a find sort of string to see if it's in the hash map or not. What am I gonna do here? Be fair, I could just save this here still. Okay, so if it's not in the hash map yet, then I'm gonna push it back as the first word, and I'm gonna delete this clause because it's irrelevant. And now instead of going through the entries, I could flatten the hash map by going through the first words instead. So let's see, word in the first words. I really like the auto completion here.
It's pretty
And
fancy
then,
for an online
right?
IDE. Yeah.
Yeah, totally. So I'm gonna push it back like this. And since we no longer have the entry, so I would just grab the value instead. So I'm gonna do stored word, and I'm return the result. Mm, does this make sense? Would you like me to like write out some sample case and try running it, or
I don't need you to run it, but I do want to make sure you have this part clear, or make sure I'm clear on it if you're
uh
right. One of us is probably right. How many are you? How many? Let me just call it quickly. So stored words is a map. This
mhm.
returns a vector string, right?
Yes, that's correct.
How many vector strings are you pushing to res right now?
How many vector string am I pushing to Chris? It depends on how many groups there are, right?
Is it always equal to the number of groups? In this case, this is where you're checking the uniqueness of a group, right?
Hmm.
Okay. Okay,
Yeah,
then it makes sense.
it
So
should.
you're only adding
Yeah.
to first word for first words when it's when the group does not exist yet in the store.
Yes. 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 That's correct.
Okay.
So yeah. Yeah. It should definitely be the same number. Yeah.
Okay, yeah, that makes sense to me. Okay, can we go
Sounds
through the
great.
time and space complexities of this method?
Yes, definitely. Okay. It's let's see. So let's say we have n number of strings. Hmm, let's see. Okay, so we are sorting the string here, and I did mention that the time complexity of sorting the string using bucket sort is O of n,
And what is n?
which depends on the number of character in a string. And we also so in this loop we're also looping through all the all the strings. So that would mean that the time complexity for the entire loop here would be the product of the strings and the product of the strings and each uh, and the number of characters. So yeah, so how do I explain this a little bit better? Um, oh yeah, instead of thinking about that, if we just think if we just think of the input as the as like and as like a number of characters, then this entire loop would be just O of n.
Okay.
Kinda makes
Okay.
yeah.
What is
This
in here?
entire loop would
Okay, can we clarify what n is here?
uh for this one.
Yeah, like you're saying O of n. What is
Uh
n?
sorry, sorry, what do you mean? Like
Yeah, what is
what's
n
the
equal
time
to?
complexity of
No, like what is so you're saying something is that's how I do comments in C plus plus or something is to say
mhm.
O of n times m. That's what you said the first time.
Yeah.
So what is n? Equals what?
Yeah. So for the first time, I mentioned that n would be the number of strings
Okay, number of
and
strings.
yeah, m would be the number of characters. But I didn't realize that each strings can have different number of characters.
Mm-hmm.
So we can't really denote m as like just like characters, right? So the next time around, I would define it all just O of n, and n would just be the number of characters in the entire vector of strings. So if I combine all the strings into one string and I count how many characters in that vector, I would have n, and that would depend on and that would be the time complexity of this loop.
Okay, so you're saying n is the total number of characters for all the
Yeah,
strings added up in the array.
yeah,
Okay. Okay, I see.
yeah,
That's yeah, that makes sense. Okay. I see.
yeah, and yeah. So and for this one, it's pretty simple. Like we're not like the worst case that we're going through like all we're going through all the all the strings in the array, and yeah, it should be less than the number of characters anyway. So yeah, should be less or equal to number of characters anyway.
Okay. Okay,
Yeah.
and that's the time. What's the space?
Oh yeah, space. Space is definitely a pickle here. Um, let's look at the helper function first. So space in this helper function would just be constant. Well, 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 constant with a slight caveat because constant because we always allocate 26
Mm-hmm.
buckets. But the caveat here is that we always create a new string to return it. So that would mean that and that would depend on this loop. So that means that for every call to the sort string, it's going to return a new string. And since we have, let's say, m number of like n number of strings, for example, that would mean that we are creating n more space here. Similarly,
We already used n
uh,
for the number of characters. Maybe you can pick a different variable.
oh yeah, Oh yeah, M. Let's say M.
Okay, m is the number of strings.
And yeah,
Okay.
yeah, and yeah, and this would be um yeah. So for this here, it would create M extra space for the returning string, and would store in the hash map right here.
Sorry, m extra.
And
Sorry to clear. M extra space for the returning string. So one string that's being returned uses m space.
no, one string return is no, one string is only be returning. Well, for each string, we're getting a new string, and
Yeah.
since we have M strings, we get M extra space for that.
And how much space per
This,
string is that?
how much space? Oh, that would be number of characters. Yeah,
Number
yeah,
of
you're right.
characters as an in, or a different number of characters?
And yeah, N characters. Yeah.
So
You're right.
in characters,
Uh,
I want to clarify because you're saying, okay,
mm,
so we have m strings. Okay,
mm,
you say each. So there's m multiples of however much memory this is, right? That's what you're saying because you call this
uh,
function m times. So you allocate m reses.
yeah.
Okay, and how much? Okay, and I'm asking you now. So per allocation, like per m,
Hmm.
how much memory are you allocating? Or you can answer if it's easier for you, for all of the m's summed together, how
Hmm.
much space are you allocating for the strings? So you can answer however you want.
It
I just want the precise answer here.
yeah. So just to make it precise, for all the for all the rest summing up together, it would be n n characters extra space. So
Okay.
just to make it just to make consistent with like with our time complexity,
Okay.
uh,
Yep.
that would be like n characters, and yeah,
In characters for all
and
of m together.
for all n together, yeah.
Okay. Okay. I'm happy with that.
Hmm. And okay, and now to this part, like to the vector string. Here it's essentially creating a copy of the string, but the copy of the string, but it should be fine. It still should be O of n space or O of m words. And same thing for first words. Like the worst case scenario would just be there's only one string in one group. So it would just the same thing happens. We would get a new vector of m string, or if we combine it all together, we would also just have n characters, extra space.
Okay.
And yeah, that's basically it.
Okay. And so in total, what's the space complexity?
In total, the space complexity should be O of n, where n is the characters, is the number of characters.
Okay. Okay. Cool.
Yeah.
Um. Okay, that makes sense. Let's move on. So I want to ask
Mhm.
maybe a couple of follow-ups about this one. So the
Yeah.
first thing is we previously grouped this based on whether or not strings are whether or not strings share some anagram, right? And that
Hmm.
makes and that makes sense to me. Um,
Hmm.
we can extend this problem. I think I don't know how far we'll get. We can extend this problem such that we
Hmm.
don't want to group them only based on for example, what specific anagrams they are currently part of, but what anagrams they can be part of if you are allowed to add any given character. So let me give an example. In this case,
Hmm.
we assume that A and B are not anagrams. That makes sense. Let's
Hmm.
say that just for example, we can modify any given character. So add, remove, or modify. In this case, for anagrams, adding characters and removing characters is the same thing. But so let's just say for this context, you can change a character. So we can change A. So in this case, the result should not be this. It should be A B. And the reason is because we can make these two the same anagram by modifying. We can do rules. We can do A turn to B, right? Or B turn to A.
Hmm.
So either way, if we apply either of these changes, they
Hmm.
would become an anagram.
Hmm.
So given this rule where you're
I
allowed to
see.
change any character and then
Hmm.
check if there is an anagram, can you
Hmm.
now tell me what needs to change?
Are there any restrictions on the number,
You can
like how many
change
changes are we
you
gonna?
can change 0 or 1.
Oh, 0 or 1.
Yep, 0 or 1.
And I'm trying to minimize the number of groups
You're
or
not trying to minimize the number of groups, so you can return any valid grouping.
any valid grouping.
So for example,
Mhm.
I mean, you are trying to minimize groups if you can, but there's a tiebreaker in that case. So yeah, you are trying to minimize groups, but sometimes it'll be more than one
Mhm.
valid group. In that case, any one of the valid groups that have the minimum groupings will be okay.
I see. Oh, I see. So it's essentially as like if I could change, I should change the character to make it into grouping.
Yeah, so previously, if you have two groups in a, so for example, A and B would previously be two groups where A and B are separate groups. Now,
Right.
even though A and B is still a valid way to, still a valid anagram, still valid
Mhm.
grouping, that wouldn't be the minimum grouping. And the minimum grouping would be either
Ah, I
changing A
see.
to B or B to A, where then they will be a
I
minimum
see.
grouping. So in this case, you can
I
return,
see. I see.
yeah. So this is kind of the way to, yeah.
I see. I see. I see. I see. Okay. What can I change about this? Can I really change about this? Hmm. That's a really good question, actually.
It is a good question. Thank you
Mhm.
very much.
Um, would I and okay, because right now it's a little bit unclear to me
Go ahead.
because say for example, if I have mm, so is that one change like one change total or is it one change per word or is it one change per anything at all?
It is, yeah. That's a good clarification. So in addition to this, let's say we can have a rule. So I can pass
Mm,
in A B so input, right?
mm.
So input and B. So what do you call this thing? Group anagrams. That's because you saw the question before, but that's cool, right? And I can pass in a rule.
Oh,
Very cool.
actually,
You haven't seen this? If you haven't seen this already, I think you're doing really good. So put a rule. B can
mm.
turn into A. Okay.
Ah,
And
I
so in
see.
this case, okay, you know what? Let's do this. Let's do it this way. Let's do it two ways. A, B, and C. All
Mm,
right. You can turn into A. So in this case, the correct grouping would be to group
mm.
A and B. So whoops, A
Ah,
and
I
B,
see.
and then
I
C.
see. I see. I see.
Understand?
I see. I see. That makes a lot of sense. And can I use like this rule and like how how many times I want or
Yes, you can use it
just
0 or 1 times per string.
per I see, I see, I see, I see. I see. Let's see. And say for example, let's if I have something like a uh if I have like two groups, um A and AA and then AB and AB, for example.
Mm-hmm.
Oh, so I would try and minimize this as well. I see.
Yeah, so to each of the strings in this group, you can apply the rule to, and they'll be a one group after.
I see, I see. Okay, that makes it harder, but I don't think it's impossible to do. Hmm,
It's definitely not
I
impossible.
see.
Let's instead do this. Can you
Mm,
talk? We don't need to implement this. I want to just
mm,
talk through some intuition,
okay.
right? So,
Mm,
first question I'll ask is it possible in this new world that you have more groups than before?
more groups than before. Health? Well, let's think about it first before I answer. If I change, if I change it to min, if I change to try and minimize it, I don't think I would get more group than before because yeah, I don't think I would get more groups than before.
Mm-hmm. Yeah,
Mm,
that's right. And what's the reasoning for that? Do you have like a quick chain of reasoning for that?
well, yeah. Um, let's say we have two groups, and first group has two elements, and the second group has one element, for example.
Mm-hmm.
Uh, like the ideal situation is that we change the one element to merge with the other one, and that would be less than that's less than two groups. But in the case where we want, say for example, we want to um change one of the string in the two elements, and it would just switch from one anagram to, oh no, it could be more groups than before. Yeah, it could actually, yeah, it could
Oh,
definitely be more groups.
slow down there. Can you give me an
Sorry.
example? Can you give me an example where it can be more groups?
Yep, 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 absolutely. So let's say, for example, I have, let's see, I have AA, AA, and then I have um AC, for example, and my rule is A to B. Can I just not can it not become AA, AB, and AC?
You could, but that would be a suboptimal answer. So that would not be a
Right.
correct output.
Oh, so we're asking the question in terms of if we try to minimize it, right?
Yeah, that's right.
Oh, okay. If we're trying to minimize it, I don't think it should be. It shouldn't create more groups because if we try to minimize, um, yeah, if we try to minimize it, like we try to merge two groups into one, I don't think there's a way to make it more. It's either we don't have a solution for that, or um, if we merge two groups into one, um, it's definitely decreasing. So
Hmm.
it shouldn't be increasing.
That's right. In other words,
Mhm.
if applying a rule will cause us to increase the number of groups, just don't apply the rule.
I see.
Mm-hmm.
Okay,
Okay.
that makes
So,
sense.
so we can use that as
Ah,
like
I
a
see.
place to start. Maybe another
I
question I
see.
can help you lead on because I want you to be able to think of some
Hmm.
like ideas yourself as well. But one more question to help you lead on is um,
Hmm.
at every point. So in your loop, let's say you don't have to use a loop, of course. I'm just saying in your given loop, we always we sort the string, right? So we
Hmm.
assume that the string is only part of one group, right? Is there something you can kind of think of for storing uh, a string, as well as if you had applied the rule to it?
Sorry, could you repeat the questions? I didn't
Yeah, for
quite
sure.
catch that.
The current implementation without substitution means that every string has exactly one correct answer for a sort string.
I see.
Right. When the rule is
Hmm.
allowed, there can be more than one correct answer for a sort string.
Oh, I see. That would be two. Yeah.
There can be more than two as well.
Oh, oh, really?
One question you didn't ask is what if there are two characters in the row? So for example, you have AA, and the rule is A to B.
Hmm.
You didn't ask if this means you can go BB or not, or is it just AB? So for this, I'll tell you that you can pick. So in this case, in other words, you can pick which of the two characters you want. So you can only modify one character.
Oh, so this is like a kind of like a bi-directional thing?
It's not exactly bidirectional, but it technically is bidirectional, right? Think about
I
it this way.
see. I see.
So let's say we can only change A to B. You have A and B.
Mm,
This is bidirectional
right.
because these are the same. So this is the same as
Mm.
changing B to A. Do you see what I mean? If A can be turned into
Oh,
B at any point,
right, right, right,
then
right, right.
then B is equal to A. So in other words, put it this way, is that because you can change one character, zero or one character in any string,
Mm,
sort string
right.
can have zero or one. A given string can have zero or one sort string outputs, depending on if you made a substitution or not.
Mm,
And more importantly, if you have duplicate characters, um, there can be even more than one if you choose to use a different character to output. So AA sorted out can either be so sorted can either be
mm-hmm.
it could be AA, AB, or BA. So these are the three strings possible. Now you'll notice that because it's the same character, these two sort into the same string because these two are anagrams,
Yeah.
right? So in this case, it is actually the case that even if you have duplicate characters, for example, you have AA, it doesn't matter if you choose the first A or the second A to perform the rule on, because A,
Mm-hmm.
B, and B
Mm-hmm.
are
Yeah, that makes
anagrams.
sense.
So
Yeah, that makes sense.
yeah. So no matter how many characters there will always only be zero or one outputs for sorted.
I see. That makes sense.
Mm-hmm.
Okay, that makes sense. That makes a lot of sense. And just to clarify though, like let's say I have AB, am I allowed to change from B to A, or
No, the rule only allows you to go from A to B.
Oh, I see. Oh, that's what you mean. Why it's not bidirectional? I see. Um.
Yep, but if these were your two strings, sorry,
Mm-hmm,
if you had these four strings, then they would be in the same group. Because even though B doesn't equal A, you can change A to B in each of these.
mm-hmm. I see. I see. I see. I see. That definitely makes it a little bit more complicated. But yeah, it's not too hard now that you break it down. So I guess like the main the first place that I would look into changing this would be in the source string function because like you say could uh it could or could not change from one character to another, right? So that would mean that we have two different results. So it's like when I sort it, I'll probably I'll I'll probably change um I'll probably have like conditional somewhere here to change I mean before reconstructing the string, I would just do my change there. I would apply the rule there to change A to B or to keep it the same. And in
Mm-hmm.
the end, I would just return the string here. I would just I would just return uh, a tuple or like a vector of size two back.
Okay.
Yeah, and then you say that okay, now it gets a little bit more complicated here because we we now have a sorted string, like two entries. So now we would have two different sorted string, like so AB and AA pointing to the same string. And this would be a little bit more complicated because if we use the same method to flatten the hash map, we would get duplicated values or the duplicated strings back, and we would not want that. So what can we do here? Let's see. So I'm pushing back string. Um, are
Mm-hmm.
we still like everything is still considered? Yeah, okay.
That's not really, yeah, it's okay. Like
Yeah, yeah, we can
that part's
ignore this
fine.
for now.
Yeah.
Yeah, we can ignore this for now. Um, okay, so if we have two of them, so how can we merge without too many problems?
Do we need to
And how
merge?
do we decide which
Why do we
we
need to
need?
merge? Or in other words, can you clarify what merging means in this context?
Uh, yes. Because right now, when I flatten it, what I would just do is I combine the the second entry. I mean the value of the entry
Mm-hmm.
together. So that would just become AA and AA. I mean like two different groups, but the same string is exists in two different groups. That's what I mean by that's what I mean by merging. Like I want to prevent this from happening.
Mm,
Does that make sense?
I
And also
okay.
like yeah, and also like uh since uh since we have that would also make it such that we have like the uh double the output. So I want to be able to identify which one is which of the two paths I'm taking essentially.
Mm-hmm. Okay.
Does that make sense? Oh, um,
I think I see what you mean now. Yeah. Okay.
yeah,
Okay. And
yeah,
by path, I want to just be clear. We don't have that much time. We'll do like 2 more minutes of just this quick kind of train of thought.
yeah,
The
yeah,
path you mean
definitely.
in this context is
Mhm.
do I choose to do the substitution or not? That's what you mean by path, right?
Yes, that's correct.
Okay. And how do you know if you made the right path? And like, how do you know if you should take it or not?
Yeah, that's definitely what I'm trying to figure out right now. Mm, so let's see.
In other words, like at any given point of iteration,
Hmm.
you have a lot of choices. right? So
Mm-hmm.
every string will branch out two paths,
Mm-hmm.
or every string will branch out up to two paths. Because if it doesn't have a character that can be applied for the rule, then it can't branch, right? So,
Right.
but you know, worst case, every character can branch out two paths.
Right. I see.
Okay, so you iterate through everything. Everything has two paths. How do you start reconciling that? In other words, right, we're at the end of the iteration. We have generated both sort strings for every string.
Mm-hmm.
Previously, when we didn't consider the substitution, we just grouped them as is, which is a sorted string. Now,
Mm-hmm.
can you like what's your intuition for how do we group twice as many strings? Is it twice as many strings, or is it more complex than that, perhaps?
And, the worst case uh where there are no groupings, even when we change it, there would be twice as many strings. That's the worst case.
Yeah.
And and yeah, and like you mentioned, like we could take each path and it kind of branches out. And the worst thing that we could do is that we can just depth search on this and try to like if uh try like if yeah like just try and brute force everything. But I'm trying to think like if I have like if I have two hash maps, one store uh uh with and one store the original, so that would be like two alternate universe if you could think about it like that. Like I'm trying to think like
Okay.
if I'm able to do that and then compare the size uh compare the size of groupings and then flatten whichever one that is minimized.
Oh, so you're talking like a backtracking approach where you pick a path, you go to the end, you group it, see the size, and depending on whether that number of groups is more like there's more or
Yeah,
fewer groups, you decide on going back a path.
yeah, well, yeah, that's the brute force approach,
Uh huh.
right?
Yeah.
Yeah, I was thinking like, what if I'm not brute forcing, or what if I have like two maps like this, and this one is like, switch, for example. I'm trying to think like, if I if I store the switch string in here, and the original string in here,
Mm-hmm.
I'm trying to think like if I could do that and still able to like at the end I would just like compare the size of these two hash maps and then flatten whichever one is minimized, if
Right,
that makes sense.
but you can choose only a subset of strings to be switched, right? You don't have to switch all of them.
Yeah, that's true. That's true.
So there's a bit of
Um,
complexity there, right?
yeah, there's a little bit.
Yeah.
Yeah.
Okay, that's a tough
Mm,
problem. Let's pause here for today.
yeah,
Um,
for sure.
you made it pretty far though. At least I think the base question, which is just a regular group anagram question, that part you went through pretty
Hmm.
quickly. So I don't think I
Hmm.
think for the the given level of the interview wouldn't have been a problem, right? So I think that
Hmm.
I had a couple of notes here. Some good things that happened, right? First good thing was you clarified
Hmm.
the input space for the characters. Right, that's a good clarification question, and that's a reason I gave you the hard follow up, not the easy follow up. The easy follow up, by the way, is
Hmm.
what if we allowed ASCII? What if we allowed Unicode? What if we had any arbitrary key?
Oh, I see. I
Right.
see. I see.
So then the question is essentially you can't use bucket sort anymore. You need to use something else.
Hmm.
The output type was good. You clarified the output type was a list of groups, which is a list of strings. Right. One thing you didn't clarify, which caused you a bit of time at the end, which is that anytime the return type is an ordered structure, such as a vector, it has an
Hmm.
order. And so not only you can't just stop at knowing what the type is, you have to know what the order is, right? And so this is something which is generally true, not just for this problem, but any problem where you return an ordered structure. You have to know what
Ah, I
the
see.
ordering is, right?
I see. I see.
Good that you clarified the anagrams. Good that you wrote a unit test or two unit tests to kind of begin with. That's always a good thing. Um, it's always a good thing. One thing depending on like if you're confident, one thing I would consider or recommend is also just quickly clarifying the edge cases. I don't think that's like a big deal for at least for me. I don't really care, but some interviewers really do care
Hmm.
about that. So, for example,
I
some
see.
people really care about um, you checking null and empty, right? So those are the two
Mm-hmm.
for vector strings. The only possible is null or empty, right? So that's something which some
I see.
people want you to care about, some people don't care,
Mm-hmm.
etc. Right? So just at least say it, right? At least say it.
Mm-hmm.
This is a bit of a nitpick, but I wanted to mention this because you said this quite confidently, and I want to just make sure we're on the same page, which is that
Mm-hmm.
it is true that if you were to store the frequencies in an unordered map, comparing maps would be linear to the number of, would be linear, right? But
Mm-hmm.
that is actually not true because there can only
Oh,
be at most 26 keys in the map.
that's true. That's true.
So while
That's
it
very
is
true.
true that it is linear with the size of the map, I gave you that one, by the way. I went to the docs and checked it. Um,
Uh,
your conclusion is not correct, right? So the conclusion is that there should be that the comparison of two unordered maps with a fixed number of keys at most 26 keys is still constant time, right? So
I
that's
see. Okay.
that was objectively wrong, but not a big deal. But it was wrong. So
I see.
just be aware of that, okay?
I
And
see.
in
I see.
general, you have to. In general, there's also one thing I would say that for more advanced problems, which is what's called,
Mm-hmm.
I don't know what it's technically called in CS, but it's what I call a counting hash. This is something which you can use to um, constant time compare any unordered map uh,
Oh.
with an increasing error. So how this works is every time you add to a map, you hash the input with the given state,
Mm-hmm.
and then at any given point you can compare the two hashes. Right, that's constant time. That's constant to the size of your state. So for example, in an int.
I
Okay.
see.
Now the more items you add to this map, the more error that will be introduced because you're storing the state of
Mm-hmm.
an infinite size object in a fixed bit width. Right, so there's increasing error.
Mm-hmm.
But this is what's in
Mm-hmm.
computer science known as a Bloom filter. So you can go look at Bloom filters in the future. Bloom filters are very cool. They're very practical, but
Oh.
not for Leetcode. Just be aware that when you say structures, when you say things like, "Oh, you cannot compare this in constant time," the interviewer is
Mm-hmm.
probably going to say, hold on a second. Yeah. So just be aware of that,
I
okay?
see. I see. I actually meant to say it's not because of that. I actually meant to say like for hash map,
Uh huh.
like you need to calculate the hash and everything. And for sorting buckets, it's much faster to do it like using bucket sort
Yes, but
instead.
calculating the hash is the same complexity as this because you're still iterating over all the characters in the string.
Yeah, I guess so. Yeah,
So
that's
this
true.
is the same. This operation here is the same as calculating the hash, except of instead of
Mm-hmm.
incrementing the bucket, you just increment or not increment. You XOR with a different variable, right? So it's the
I
same
see.
complexity
I see.
still.
Okay.
So it's
Okay. I
yeah.
see. I see. I see.
Okay,
Mm-hmm.
okay, okay. Blah blah. Return order. Okay, yeah. So time space complexity was correct. That was good. One thing I
Mm-hmm.
will say though is when you use in to define the total number of characters in the entire input space, that's a bit of a cop out answer. Okay. The more precise way to define it is actually to introduce the variables you need. So it actually is practical in this case to say that the in is a number of strings in the input vector, and you can in this case to mitigate your concern about the different number of length per word, you can say that n is the length of the longest word in the input, because this is a big O
Mm-hmm.
complex analysis, and therefore you can assume that the worst case, right? That would
I
have
see.
given you a more precise answer, because even though you define in as n times m, essentially what I'm saying, that's still correct,
Mm-hmm.
but that's viewed as less precise.
I
So
see.
so
Wait, so, uh, mhm.
go ahead.
Sorry, um, so you're saying I should define n as the number of words of the longest string then?
No,
Is that what
what?
is?
So let me do this way. So the more precise way to define this. So first of all, what you do is correct. So your space and time complexity analysis is correct. What I'm saying is that
Mm-hmm.
a lot of things are correct if you just define n to be the total size of the input space, right? That's not that interesting. Okay, so the more
I
precise
see.
way to define it is this. I'm using different variables, so it's not confusing. Okay, so n is the
Mm-hmm.
length of r. Okay, and then I'm too much
Mm-hmm.
Python today. And then you can say what's that? Let's use x, sure,
Mm-hmm.
whatever. Is the max len of a string in r. Okay, and you can say your overall complexity
Ah,
then in this case is going to be O of t xt, and then
I see. I see. I see.
right. And the reason you can
I
do
see.
this is because we're doing big O analysis, right? Instead,
Mm-hmm.
if you had so not to say this algorithm, actually this algorithm would actually apply. If you're doing theta analysis or average case analysis, then you would do
Mm-hmm.
then you can define this as how do I do this? Is it this? No, that's not it. Is it? Oh, that's not it. Okay, I'm just copy it regularly. You can define this as the average, right? And then you can do yt. So these are things you
Ah.
can do if you can. So, but don't offer theta unless you're very very confident. Just but it's okay to say max because you're doing big O analysis, and that's the worst case, right?
Mhm.
So worst case
I
is
see,
that
I see,
every string is as long as the longest string. That's the worst case, and therefore so
I
this would be
see.
correct.
That makes sense. I see.
Okay. Blah blah. Oh, one thing also. Okay. Also another thing I will say, which is correct. Which again,
Mhm.
your analysis is correct, but is not very
Mhm.
precise. Which is that
I
you
see.
did not say that the unordered map does not take extra memory, right? So this is not given because this is a library you're using, or not library. This is a standard library you're using, right? And so it's okay to
Oh.
assume that the vector does not require extra space on top of your linear space because a vector is just an array, and an array we can assume the complexity of. However, if we're using standard library stuff, like for example maps, it's also good to just say, oh, the map does not require extra memory for tracking. Because for example,
Oh, I see.
if you're using a, let's just say, a B tree, a B tree
Mhm.
holds n items but uses n log n space because it has to hold all of the intermediate leaves, right? So that's an example.
I
I'm not
see.
like you're not doing it in this case, but it's not always true that just because you store n items it uses n space. So just be
I
aware that
see.
that is a detail which is good to just say because I'm sure you know it, right? You just didn't say it, so that's something you can
Mhm.
definitely work on.
Mhm. That makes sense. That makes a lot of sense.
Okay, cool. Last thing, the follow up is not easy. The follow up is a hard question on purpose because I didn't get a signal on you actually thinking about anything because the way you ran through the first part of the question was too easy. So the signal I
Yeah.
got from the second part about the hard follow up is that you can definitely take a bit of time, slow down, write the examples like you did, and then
Mhm.
just start with a naive basic approach, right?
Ah.
You don't if you find yourself actually truly stuck on an issue, you don't need to
Mhm.
think until you find an optimal one, or until you
Right.
think you found the optimal one, right? Because for example, if you had thought sound the problem for 10, 15 minutes, and then you wrote that you can just compare two of the groups at the end, that would have not looked as good because that's also wrong. Because that wouldn't have looked as good. It's as if you just said, okay, I'm not sure what the best approach is. I'm going to write the brute force one and then iterate as I go. Right? Then at least you can
I
get
see.
an answer on the page instead of thinking for a while and risking writing an incorrect one. Right? So just be
I
aware
see.
that that's a false trade off. You can get started once you start thinking about things, and if you can't think of something that's optimal, you can just get started on a approach at least.
That makes sense. Okay. Mhm.
Okay, cool. Any questions on your side?
Yeah, yeah, definitely a few. Just like I remember you advising like your advice from the past mocks,
Uh huh.
that I should converse with the interviewer as much as I could.
Yes.
Was that an appropriate amount,
That was very
or
good.
I
That
didn't
was
really?
very good. I like that. So,
Okay.
a couple things that were good. I didn't write the things down, but a couple things that are good was
Mm,
you checked in on the understanding frequently. That was good. You checked in
okay.
on whether or not we needed to test a certain implementation. That's good. That's a good confidence signal. And then you also were
I
good
see.
in checking for specific correctness, right?
Ah, I
Because
see.
like offering to write unit tests is for is just for confidence, but checking correctness is just makes it's like a shortcut, right? It's a
Hmm.
shortcut because, for example, if you had asked me, is this correct? I said I'm not sure. Then you can write the test to kind of walk me through it. If you asked me, is this correct? I said, yeah, it's fine. Then you can save yourself some time. So that was appropriate. And
Ah,
that was quite good. Yeah.
I see. I see. That sounds great. And yeah, and that's actually all actually. Thank you
Okay.
so much.
Awesome.
Thank
Okay.
you very
Well,
much.
thank you very much, man, for your time. Thank you for
Yeah.
substituting in for someone else today. I know
Yeah.
you didn't have that
Absolutely.
much time to prepare, but I think it should be quite well
No
overall.
worries. No worries at all. Thank you so much.
Okay. Take care.
Thanks. Have a good night.
Bye bye. Take care.
Bye bye.
Let me just quickly look at chat before I end the stream. Did I miss anything? Don't think so. Order rate based on original. Yeah. Okay. I wonder if there's any spicy follow-ups for this. This question has a couple follow-ups. The one I gave today is a variation of two problems. The not two pro. What there's this problem Leetcode. I forgot what it's called. Honestly, I look at these problems. I don't even do these Leetcode problems. I just saw them from someone else asking me them a while ago. There's a problem that's essentially called minimum number of swaps to make strings equal or something, which is essentially this question but backwards, which is can you swap something once to make strings anagrams? Or in other words, if you sort two strings, right, then if you can swap one character, then they are anagrams. So there's a bit of a math. I won't say math. There's a bit of like an anagram math kind of question here. A bit of a tracking question here with minimizing groups, etc. Um, some other follow-ups. There's always a classic follow-up of turning this algorithm into an online algorithm, right? So if you just ignore the swaps, if you go back to the original problem, can you refactor this into a class that has add, remove, and check? Right. For this problem, it's fairly trivial since it's just add and remove from maps. That's not really as difficult or a skill, but that's always a follow up you can use to gauge someone's like raw programming skills. For example, this person was quite strong at C++. I'm not concerned about that. But if someone's really struggling with the types, the syntax, you can use that as a way to kind of judge if they, if they really know what's going on. Why are there only 26 keys? Why is my screen glitching? Why are there only 26 keys in a hash map? Isn't that dependent on the number of groups? More than 26 keys in a hash map. I'm not sure. Do you mean this bucket? That's the only place he hard-coded 26. The reason it's 26 is because there are only 26 lowercase alphabet characters, which I allowed them to assume. Cool. That will be all for today, everyone. Take care. Thanks for tuning in. We'll probably be back next Saturday if I don't get anyone scheduled for the weekdays, which I probably won't for this week, but yeah. Okay, everyone. Bye-bye.